Hello class and welcome to This Week in AP Chemistry. Today we're going to explore the wonders of cobalt as we continue to explore the periodic table. We're going to look at cobalt's properties and bonding, its uses, how it's mined and extracted, any toxicological effects it might have, and ultimately how is it quantified in its matrices. I do want you to pay attention to the fact that every picture and every piece of information I present is cited within text citations and full references are at the end. Before we begin, I would like you to look at these pictures and determine what they all have in common. Tesla, an electric vehicle, vitamin B12, hip replacements, magnets, wind turbines, and even your cell phone. That's right, these all contain cobalt. As I stated earlier, you're going to be exploring cobalt's properties and bonding, uses, mining and extraction, any toxicological effects it might have, how we quantify it in its matrix, and we're going to look at the current research. This presentation is actually twofold. Not only will we look at cobalt and its prominence in the world and its potential dangers, but you're going to prepare to do a research paper. So throughout this week, you're going to practice your research techniques. You're going to look a little bit further at cobalt compounds and their uses, elements that could replace cobalt, and then you're going to practice paraphrasing, very important in your research project. And the last thing you're going to do is research your own element and write your own paper. During this week, we will be spending our time listening to a few lectures like this one. I've got a video I'd like to share with you, some questions to think about, discussion questions as we usually do. I do have a homework assignment and ultimately the research paper. While you are watching this video, I suggest you take notes. Not everything that I say is going to be on the PowerPoint. This information will help guide you on your discussion questions, homework, and research paper. You'll also be presented with some interesting questions to consider. Before we jump into cobalt and all of its uses and properties, I'd like to take a quick look at a video. Is the world's desire for cobalt slowly destroying Earth? I want you to go ahead and pause this video, go to YouTube and look at this video. You only need to watch the first minute and a half or so and take a look at how cobalt is mined in the Congo. I would play it in its entirety here, but if I turn this file into a movie, it won't play.
As we continue to explore the periodic table, we're going to take a deeper dive into why we need cobalt and what we can do to protect the environment. By understanding cobalt's properties, bonding, and uses, you will understand why we need cobalt. Understanding how cobalt is mined and extracted and how it can negatively affect living things will help you to understand why we need to be able to quantify cobalt concentrations and monitor those levels. Current research is needed to find alternatives to cobalt and new methods of quantitative analysis to ensure we maintain safety. Before we get into cobalt's uses, let's take a quick look at its properties because it will explain those uses. If you look at cobalt's electron configuration, it has an odd number of valence electrons that is very important to some of its uses. It is a silvery, bluish-whitish hard metal that's very dense, has high melting and boiling points just like other metals. It does demonstrate ferromagnetism. It has two different kinds of solid structure. At temperatures less than 417 degrees Celsius, you'll find hexagonal close packing. But as those temperatures reach the melting point, you tend to see face-centered cubic packing. Its chemical properties are kind of boring. For the most part, it's really relatively unreactive. Cobalt has two oxidation states, +2, which is what we normally find. +3 exists at higher temperatures, and that +3 is the more oxidizing form. Cobalt will also dissolve in acid. Cobalt can form many compounds. Because of the odd number of valence electrons, it's great as a supermagnet when combined with samarium. It forms a variety of oxides with that generic formula. Notice both oxidative states, the +2 and +3, are in that formula, but the +3 always exists 2 to 1 to the +2. It forms both low and high spin metal complexes that can take on an octahedral shape. Metal complexes do violate the 18 electron rule simply because cobalt has an odd number of valence electrons. And various ligands can attach to the cobalt. This is awesome for its catalytic purposes. Now, I'd like to talk about one of your DQ questions for the week. I didn't go into many details about the compounds on purpose. I want you to look up examples of cobalt compounds, explain their physical characteristics and their uses. You must find at least 3 different types of cobalt compounds, cite the sources, share them on Canvas, our learning management system, under the DQ number 1. And make sure you respond to other people's DQs. Cobalt has a vast array of uses in the medical field, industry, the art world, and within the human body. Let's take a look at each of these in turn. Cobalt is very important to the human body. First of all, cobalt is the core of vitamin B12, which is necessary for humans to make red blood cells which carry oxygen throughout the body. Cobalt comprises enzymes vital to mitosis, which is important in making new cells. It's also used to make amino acids and proteins. Those proteins can go on to make myelin sheath to create neurotransmitters. And most enzymes in the human body require cobalt. Cobalt has many important uses in the medical industry. Cobalt-60, a radioactive form of cobalt, is used in radiation therapy, while radioactive cobalt-57 is used for medical testing, sterilizing medical equipment, and even food. Because cobalt is so strong, it is used in knee and hip replacements and even dental implants. The cobalt chromium molybdenum alloy has less allergic reactions. Moreover, there are cobalt chromium biomaterials being developed that may affect gene expression in regrow tissue. And that research is also trying to shed some light on why implants break down and are not successful. Because cobalt is corrosive, wear, and temperature resistant, it is widely used in machinery. In fact, it was widely used in World Wars I and II, so much so that in 1946, the U.S. government passed a law to stockpile cobalt for industry and military uses. Cobalt chromium creates a very strong metal alloy. Cobalt nickel alloys resist changes in temperatures, and it's these alloys that are used to make the wind turbines and the jet engines. Alloys of cobalt, nickel, iron, and aluminum are used in magnets. Cemented carbides make great tools and drill bits and saws because they're so strong. In batteries, the cathodes are created with cobalt. These are used in lithium-ion batteries as well as nickel-cadmium batteries. The cobalt is safe, stable, it has a high energy density, it's long-lasting. And of course, these rechargeable batteries are used in so many things, including electric vehicles, bikes, tools, phones, watches, game controllers, digital cameras, iPads, other tablets, and computers. The use of rechargeable batteries seems endless. Electroplating with cobalt increases the hardness and reduces oxidative abilities. And lastly, sometimes humidity detectors are needed, and cobalt is an excellent humidity detector. Cobalt is at the heart of many catalysts. In fact, cobalt acetate and cobalt carboxylates can be used to make acids, drying agents and paints, to make steel and rubber stick together to make tires. Cobalt catalysts are used to make fuels and alkenes. Cobalt oxide can be used to remove volatile organic compounds from air. We've used cobalt to dope a different catalyst to enhance its ability to remove air pollutants as well as aquatic pollutants. In fact, in 2022, Wang et al. Did some research where they used cobalt metal as the center with organic ligands to reduce leaching and to make it more recyclable. Well, this carbon framework with nitrogen and cobalt produced a green, efficient catalyst that was used to clean up contaminated water. Moreover, cobalt is widely used in the art world. Cobalt is great in ceramics, porcelain, pottery, and ink because it can produce both a beautiful green and blue color. Porcelain cobalt enamel increases stability and hardness. It's even used for cooking pans. We use cobalt in jewelry because it's not only less dense than platinum, but it's 4 times as hard. Cobalt compounds are used in glass, paint, rubber, ink, pottery, and even makeup. You will find cobalt oxide, cobalt potassium nitrite, cobalt aluminate, cobalt ammonium phosphate as some of those compounds. I want to stop for just a moment and ask a question. What if the world runs out of cobalt? Then what? Your second discussion question for the week is to research elements that could be used in place of cobalt, in case the world runs out. Explain the application and why the other element is a good replacement for cobalt. The point of this is for you to begin researching elements that you might find interesting that you can then develop into your research project. Clearly, cobalt is important, but where do we find it? It's found in nature, in plants, animals, water sources, soil, and ores such as cobaltite, smaltite, chloranthite, and lignite. It's found in many big deposits, including Canada, Russia, Australia, Cuba, the African countries of Zambia, Morocco, and as you saw in the video, the Democratic Republic of the Congo. 98% of cobalt is mined along with other metals such as copper and nickel, and these are found as sulfides, oxides, carbonates, arsenides, and pyrite. Now, there are some cobalt-only ores, and these are found in Morocco, some Canadian mines, and most recently in Salmon, Idaho. In fact, an Australian company opened up a mine there, and they mine it in Idaho and then process it in Brazil. Scientists also believe there is hidden cobalt in the oceanic crust in the mid-Pacific region, but it has not been explored yet. Now that we know where to find cobalt, how do we get it? Cobalt can be found through mining and extraction. Typically, we use open pit mining, which means the cobalt is near the surface. It's much cheaper, much less labor intensive. Or we use deep underground mining, which means the cobalt is at least 100 meters below the surface. Usually a combination of those two techniques is used. Higher grade ore can be obtained by hand in small mines. Once it's mined and extracted, we need to process it. First, the ore is crushed, ground, leached. We remove the impurities, we isolate, and we purify. Well, the type of ore dictates what chemical process is used to remove and purify the cobalt. This could include oxidation, high heat, reduction, pressure leaching, chloride leaching, and electrolysis. The four processes used to isolate cobalt include hydrometallurgy, which uses acid, high temperature, high pressure, which creates a salt. It's then releached with oxygen, and an oxide is added to separate the cobalt. Electrowinning solidifies cobalt onto stainless steel to be used as cathode in batteries. Vapometallurgy vaporizes metal ores with gases to remove cobalt. Pyrometallurgy uses the melting point in density to separate cobalt from ore by heating the ore. This is used in smelting. Prior to pyrometallurgy and hydrometallurgy, copper cobalt ore is often made into a concentrate and stirred to create air bubbles, and those air bubbles attract cobalt and then brings it to the surface. We know that cobalt is very useful and in fact can be necessary, but at times it can have some negative effects. Mining is dangerous. There's accidents, poor work conditions, exposure to toxic chemicals, and even violence. Now, humans need cobalt to make enzymes for metabolism. B12 is required to make red blood cells. So if we don't get enough cobalt, it can affect our ability to have red blood cells. But at the same time, too much cobalt can have negative effects. It can cause vomiting, diarrhea, skin irritation, and lung issues. Back in the 1960s, beer manufacturers added cobalt to beer to make it foam more. Well, this resulted in heart issues. Most resources agree that it could be a carcinogen. Cobalt can oxidize fats that contain double bonds. Well, fats with double bonds are found in cholesterol and our cell membranes. That's not a good thing. Cobalt in toxic levels can cause inflammation, cell and tissue death. It can affect the lungs, liver, kidneys, blood vessels, smooth muscle. Radiation exposure can cause radiation poisoning. In the Congo, they're doing research as to whether or not cobalt exposure is causing erectile dysfunction. Children are exposed to toxic levels because oftentimes they're the ones going down into the mines in the Congo. And while knee and hip replacements using cobalt can be a good thing, sometimes that cobalt breaks down and can cause cobalt poisoning. This has even caused vision loss in patients. Now, on the environmental side, cobalt can kind of go both ways. If in the environment cobalt doesn't occur in big enough amounts, it can be devastating. For example, phytoplankton require cobalt for growth and calcification. So if it doesn't get enough, that can in a way be toxic. Livestock require enough cobalt. In Australia, the sheep that lived along the coast often got coast disease. It was a wasting disease that caused anemia, hard steel-like wool, and fatigue. Plants require cobalt for enzymes, for seed growth and germination. So if they don't get enough cobalt, those things are hindered. But if plants take up too much cobalt, then those are passed on, in particular through the seed and the fruit. And then that higher level cobalt can be passed on through the food chain. So cobalt can have negative effects depending on whether or not there's too much or too little in the environment. This takes us up to our third discussion question for the week. On the discussion question forum in Canvas, I want you to choose a transition metal other than cobalt, research its importance to living things and its potential toxicological effects on them and the environment. Make sure you cite your sources, minimum word count of 100. Please respond meaningfully to at least 3 other posts. And the point of this assignment is to begin researching elements to find one of interest that you might want to develop into a full paper. Now let's take a look at the fate of cobalt in the environment. Fate simply means what happens to the contaminants. Well, cobalt can be introduced into the environment through natural mechanisms such as wind, water, fire, and volcanoes, although typically we introduce it into the environment through mining, power plants, cobalt processing, and transportation of cobalt. Once cobalt particles are in the atmosphere, it combines with particles of varying sizes, and this is what gets into the soil and water. Currently, we have a great deal of mining occurring because each electric vehicle battery that's produced requires 6 to 12 kilograms of cobalt per battery. Cobalt dust invades nearby villages, pollutes water. Mining also relies on fossil fuels, which can add to pollution as well. Nuclear reactors' cooling waters may contain cobalt. Now, we do know cobalt-free batteries are on the horizon, but even those metals can still bring environmental issues we'll need to address. But I want you to start thinking about how can we reverse or prevent some of these environmental issues. For example, Apple Corporation plans to use 100% recycled cobalt in all of their batteries by 2025. We know that cobalt is necessary. We know that it can be toxic. Therefore, we need a way to quantify cobalt in its matrix. That's just a really fancy way of saying how much cobalt is in that sample. And that sample could be blood, water, soil, plants, etc. Pay very careful attention to this slide. Take some notes because this is going to be the basis of your next homework assignment. The problem with quantifying cobalt is that first, it exists in different medium along with other elements and compounds, and these can interfere with analysis and or break equipment. Also, cobalt is tough to measure. It exists in what we call ultra trace amounts. So researchers have developed something called pre-concentration and separation. What they do is they increase the concentration of cobalt and then they separate it. Once that's been achieved, cobalt can actually be analyzed and quantified. I'm going to talk about these 6 processes under pre-concentration and separation briefly because you're going to choose one of them and do a deeper dive into how they actually occur. Cloud point extraction is simple. Green, remember we did a lab on that. That just means eco-friendly. And it's very inexpensive. It basically uses surfactants that trap cobalt, and this is used to monitor cobalt in food waste processing. Also, it can measure how much cobalt is in apples, spinach, and tomato leaves. Dispersive liquid-liquid microextraction uses 2 different solvents, one that is water-soluble, one that is not. It is also simple, quick, cheap, produces quite a bit of cobalt. The solidified floating organic drop microextraction is similar to the dispersive liquid-liquid type, but it's less toxic. It's easier to remove the solvent, and it does a better job of separating cobalt. Supramolecular solvent-based microextraction is green, good for small amounts of cobalt. And what they do is they add organic ligands to make the sample insoluble. This is very, very selective, and it's excellent in being used on environmental, biological, and food samples. The single drop microextraction is effective, eco-friendly, it uses less solvents, and it even does pre-concentration and separation in one step. The best part about this method is that it uses ionic liquids that are not toxic and volatile. The solid phase extraction is fast, easy, very selective, uses less solvents. Basically what they do here is they add a chemical that absorbs liquids. They shake the solution, spin it down so the solid with the contaminants is removed, and then the cobalt is in the solution. And there's actually quite a few different kinds of solid phase extraction that exists. Now, once scientists have achieved pre-concentration and separation, they can then analyze and actually quantify cobalt in the matrix. One is called inductively coupled plasma optical emission spectrometry. Sometimes you'll see this called inductively coupled plasma atomic emission spectrometry. Basically, they're both similar. They excite electrons which gain energy, and as the energy is lost, it emits light. And we know that through some of our labs we've done in AP Chemistry, light intensity is proportional to concentration if we use a calibration curve. Inductively coupled plasma mass spectroscopy is similar to this, but here they atomize the sample, and then the ions are separated with a mass analyzer on mass charge ratio. We actually did a worksheet on this earlier in the year. Then you have flame atomic emission spectroscopy along with flame atomic absorption spectroscopy. They're both similar. They both involve putting an aerosol sample in flame. The solvent evaporates. Some atoms gain energy. And we know that gained energy as well as light emitted can both be monitored and linked to concentration using calibration curves. So the only difference between these two is the one is monitoring energy absorbed, the other is monitoring energy released. Graphite furnace atomic absorption involves taking a liquid sample in a graphite tube, heating it, vaporizing it, and then spectrometry measures the energy absorbed, which again is linked to concentration based on a calibration curve. Many new techniques are constantly coming out. Sometimes it uses a combination of pre-concentration separation techniques, other times new twists on analysis. So you might come across these in your research because you're not only going to do a deeper dive into pre-concentration separation, you're going to take one of the analysis techniques and also go a little bit further. So here's some of those new techniques. In one case, they use inductively coupled plasma mass spectroscopy, but instead of using argon, they chose helium and has some good results. Another team wanted to analyze tea samples, chamomile tea in fact, and they used magnetic hydrogels to help remove contaminants. And they used dispersive solid phase extraction along with the flame atomic absorption spectroscopy, Others are looking at analyzing cobalt in petroleum wastewater. Now, they used a combination. They first did directly suspended droplet microextraction, followed by dispersive liquid-liquid microextraction. And then here's the key step. They did floating organic drop method. Then they used electrothermal atomic absorption spectrometry. Another unique technique was to look at how much cobalt was actually being absorbed in aquatic ecosystems. Here they use mercury and iridium microelectrode and a different technique that I have yet to talk about called absorptive square wave cathodic stripping voltammetry. Now you can use any of the pre-concentration and separation techniques and any of the analysis techniques in the next assignment. Your homework assignment this week is to practice paraphrasing. I want you to find a journal or journals that explain in detail one of the pre-concentration separation techniques and one of the analysis techniques. I want you to copy and paste at least a paragraph that explains how this technique occurs. You can copy and paste more than one if necessary. And you're going to do this for both the pre-concentration separation technique as well as analysis. You're going to paraphrase these processes. This means in your own words. And then you're going to cite your sources. And this is going to help prepare you for your research project. When you write your research paper on your element, you may want extra information you can include in your introduction and/or your conclusion. You might want to look at all of the different research that's occurring with your element. For example, researchers are looking at how cobalt can be used in environmental science, the medical industry, business, and the energy sector. So here's just one little take on current research on cobalt that involves the environment. Khan et al. Decided to look at cobalt levels in Pakistani soil, plants, and livestock. They used the atomic absorption spectrophotometry to analyze cobalt levels in those samples. What they discovered is that the soil, thus the plants and the livestock, actually had very low levels of cobalt, and they believe it was because of competition with zinc and lead in the environment. So their solution in this area of Pakistan was to not only use fertilizer in the soil, but to use food additives for the livestock. Now that we've taken a deep look into cobalt, I want you to find an element that you would like to research. And don't forget, there is much more detail on this project that can be found in Canvas in modules under Research Project. Choose an element, either a transition element or from the main group. And I want you to research its properties, bonding, uses, how it's mined and extracted, any toxicological effects it may have, and how it is quantitatively analyzed in its matrix. Also look into current research being done. Use APA format throughout. I would like you to notice that I've included all of the references for all of the material presented in this PowerPoint in my references. You will do the same in your paper. You'll also notice that any pictures I used in this PowerPoint, I gave credit to those sources on its own slide at the very end.